Hey everyone, Sebastian here. Another fun math challenge for you today about diagonals and polygons. The shape to the left is a hexagon. How many diagonals does it have? So I'm going to do this one drawing it out, and then I'm going to show you a formula for it. So with a hexagon, we have one going down this way, one going this way, one going this way, right? 3 so far. Then we have this one will also connect to this, and it'll connect to this. This one will connect to this, and it'll connect to this. This one will connect to this, and it'll connect to this. So each of them has 3, right? Each vertex has 3, and there's 6 vertices, so we do 6 times 3, and then we have to do half because otherwise we're double counting them. And that'll get us 9. Okay, so if you think about it, how do we get the 3? So the 6, where does the 6 come from? The 6 comes from each point. So let's say the points are each n. So let's say the number of points is going to be n. So that's the number of vertices. The 3 we got from how each point gets combined with all the other points besides itself, besides the 2 points it's touching in the polygon, because you can't make diagonals there. So it'll be n minus 3. And then you're dividing by 2. Okay, so that's what the formula you can derive just by drawing it out. Another way you could think about it is using combinatorics, which would be NC2 minus n, because NC2 is saying you have a certain number of points you're choosing. So in this case, it would be 6, and you're choosing 2 connections, so any 2 connections. But in this case, we're counting these as values, so we have to take them away to just get the diagonals. So in this case, we would do 6 factorial over 6 minus 2 factorial, 2 factorial, which would get us 6 factorial over 4 factorial, 2 factorial, which equals 6 times 5 over 2 equals 15, and then we do minus 6. That also gets us 9. So I think this one feels more intuitive because you see the drawing, but they work out to be the same formula. So let's try decagon together, and then we'll do a hectagon, which is too hard to draw, but you'll just have to trust the formula, and you can look it up after and see that it is correct. So decagon, how many diagonals does it have? Already at this point, drawing it out will be really tedious, so let's do the formula. N times n minus 3 over 2. So we're going to have 10 points. So we do 10 times 10 minus 3 over 2. And that's going to equal 10 times 7 over 2. And that is exactly 35. Good. And you could do it with the n choose 2, right? I'll show you that as well. So that'll be 10 factorial over 8 factorial, 2 factorial minus 10. So that's going to be 10 times 9 over 2 minus 10. That'll be 90 divided by 2 is 45. Minus 10 gets us 35. Either way, we're good. We'll do one last one, and then you'll see that you can always do these. And if you want, you could draw it out on the decagon and see that it is 35. So a hectagon equals 100 sides. So n equals 100. So we're going to do 100 times 100 minus 3 all over 2. So that's going to be 50 times 97, which will be 4,850. A lot of diagonals there, right? And then if we did it the other way, n choose 2 minus n, we'll do 100 factorial over 100 minus 2 factorial, 2 factorial minus 100. So it'll be 100 factorial over 98 factorial times 2 factorial. These cancel, so you're going to have 100 times 99 over 2, minus 100, right? We're going to have minus 100. And that will give us 4,950 minus 100, which equals 4,850. All right, so I hope that makes sense to you. If you have questions on this, let me know. But this is a fun thing to work out on your own and see why the formula exists. I think it's always better to see how a formula becomes real than just having to memorize it. So again, if you have questions, let me know. Otherwise, I hope it's sunny where you are, and if it's raining, I hope it's cleaning your windows and watering your plants. Bye.